Alright, Studio 4, here is the video that you can come back to this week to help you with your math boxes. So I'm going to quickly get into my markup and zoom in on Monday. When trying to find the approximate location of the given number, the best way is to find a number that you do know is going to be on the number line. So I'm thinking of like between 5 and 6.5. I know 6 is going to be about right here, because, and then 5.5, so 5.5 or 5 and 5/10 is going to be that middle line between 5 and 6. So same thing for B. Mark the approximate location of 7 and 5/10, 7.5 on the number line. Well, I know right in between, right in the middle of 6 and 8 is 7. And then 7 and 5/10 is going to be right in the middle of 7 and 8. So again, I found the approximate spot for this number by using different lines in my number line. Going over to Tuesday, we've done area model before. Letter A says a hot tub costs $6,299. A water park is buying 3. How much will they spend? So I'm going to multiply 6,299 times 3, and to use the area model, we're going to break 6,299 up into an expanded form, meaning the 6 is has a value of 6,000. This 2 has a value of 200. This 9 has a value of 90. This 9 has a value of 9. And then I'm multiplying it by 3 because the water park is buying 3 of these hot tubs. Then we just use our multiplication chart skills, and we're going to do 6,000 times 3 for this first box. I see the math fact of 6 and 3, which is 18. And then I add my 3 zeros. This box would be 200 times 3. 90 times 3, and 9 times 3. Once you get all of the answers for these problems, you're going to add all of those up, and then you'll put your answer in the box below. For this one, the label is going to be money, so you can put your $sign in the beginning of it. Moving to Wednesday, I'm going to give you examples of all of these lines, and then you're going to find them within the pictures. You only have to find one example out of all of the pictures. You don't have to find an example within each. So you don't have to find an example within the fox and the windmill. Parallel lines are lines that if they were to go on forever, they would never, ever, ever intersect. So those are going to be two lines that are going both up and down, both side to side, both diagonal, and they would never touch. So an example of these could be that door on the windmill, that top line and that bottom line. If those lines were to continue going forever and ever and ever, they would never touch no matter what. And then I'm going to write parallel lines to label it. Now that's the only one I'm going to show you how to do. The rest I'm just going to show you an example up in the word bank. A line segment is any line that has a start and an end point. If it was a line, it would have 2 arrows at the end to show you that the line continues on forever and ever and ever. We just can't draw it. A line segment is just a line that starts somewhere and ends somewhere. So all this picture, both of these pictures are full of line segments because they start at one point and then they end. None of them have arrows to the sides of them. Vertical lines are lines that go up and down in any way, so either straight up and down, maybe they're slanted a little bit going up and down, but then we'll get to horizontal in a little bit. Those are going to be opposite. Perpendicular lines are lines that when they meet up, they create a 90-degree angle, so they create that perfect corner. So it could be like an L, a backwards L, almost like kind of a 7-ish look. So any of those would be perpendicular lines. Horizontal lines, like I said earlier, are the opposite of vertical lines. These ones are the ones that go side to side. Again, they can be a little bit diagonal as long as they're more side to side rather than up and down. And then diagonal, those are those slanted lines that we see. So make sure you're labeling those in the pictures below. Going on to Thursday, we're crossing out Thursday. We are not doing Thursday's math boxes. So I'm going to go ahead and go on to Fridays. It says break down each fraction into smaller parts. So this arrow is wanting to know what is this piece equal to in the fraction? Well, I know the denominator, the bottom number, is how many parts there are total, shaded in or not shaded in. So 1, 2, 3, 4, 5, 6. There are 6 parts total. And then the top number is the piece that I'm actually talking about. So in this case, this arrow is only pointing to 1. So this is 1/6. This is also 1/6, 1 piece out of 6 pieces total. And then again, this is 1 piece out of 6 total. Now if I add all of these shaded pieces up, 1/6 plus 1/6 plus 1/6, I would get 3/6. Write the fraction of the unshaded portion, this question over here. Okay, so my total pieces is still the same. I still have 6 pieces total, but this time it wants to know how many are unshaded. So I'm going to count 1, 2, 3. 3 pieces out of 6 are unshaded. Math Fact Corner, you guys know what to do. Multi-step math, we got started this week. It says each of the 3 4th grade classes, so there's 3 classes, at Park Hill Elementary has 29 students. Each of the students brings 2 dozen pencils to school on the first day. How many pencils do all the students have in total? So first we need to figure out how many students there are total in the 4th grade. So if each class has 29 and there's 3 classes, we're going to do 29 times 3 to figure out how many students there are total. So go ahead and stack this like a normal multiplication problem. And then we're going to solve. 3 times 9 is 27. My 7 goes down and I carry my 2. 3 times 2 is 6, plus my 2 is 8. So there are 87 students total in 4th grade. But my question is wanting to know how many pencils all of these students brought in. But this is going to help me. This is just a step in that direction. Our word problem also says each student brings in 2 dozen pencils. Well, I know 1 dozen is equal to 12. So if I have 2 dozen, that means each kid brought in 24 pencils on the first day of school. So if I have 87 students, each bringing in, that word each reminds us to multiply. My next problem is going to be 87 times 24 to find out how many pencils the students have in total. And I'm going to leave you with this. We're going to use MZMA to help us with this tough multiplication problem. I'm going to move on to number of the week. Go ahead and cross out word form. This box is too small for you guys to write that in word form. Multiply by 10. We know that when we multiply a number by 10, we're just shifting all of those numbers over one spot to the left in those place values. So the 1 that's in the 100,000s will now go in the millions. The 2 in the 10,000s place will now go in the hundreds thousands. And then I'm just shifting my numbers over. And once I get to the ones place, I just fill in with a 0. When we're multiplying by 100, we're shifting them over 2 place values. So that 1 that's in the 100,000s is now going to go in the 10 millions. The 2 that's in the 10,000s is now going to go in the millions. And again, we're just going to keep shifting our numbers over. And when we get to the tens and ones place, we add our 2 zeros in. And it's really not as scary as we think it is. Sum of the digits, you're going to add up all the numbers that make up this number. So 1 plus 2 plus 3 plus 2 plus 1 plus 5. Okay, and then you'll solve for that. Find the factors of the value of the number in the ones place. So in the ones place is a 5. So we're going to think of all the math facts that make up 5. So 1 times 5. There's no other math facts that make up 5, so our factors for 5 are 1 and 5. The first 5 multiples of the number in the thousands place, our number in the thousands place is 3. When we're finding the multiples, we are just skip counting. So 3, 6, 9, 12, and see if you can come up with the last 2. The next 3 boxes we have done before. Find the difference. Find the difference between the number of the week and your full birthday. So, for example, my birthday is October 29th. So, October is the 10th month. So, I'll write 10, 29. And I'm going to add my comma in. So I'm going to subtract 123,215 minus my birthday in number form. So again, we're not doing the year, but you'll use the month and then the date. So if you need help figuring out what number your birthday month is, just raise your hand. A teacher can help you with that really quickly. But then I'll solve for this, and that's my difference. So our answers might be different. Well, they definitely will be different because no one has the same birthday as me. But that is math boxes for the week. Make sure you pause this video, rewind this video, fast forward this video whenever you need to throughout the week. It will always be on our daily schedule.